slowly. So it will be a term project on estimation of musculoskeletal forces and of course moments during a physiological activity using inverse dynamics. Okay. So the guidelines, the rough guidelines for preparing the project, as you can see, the project report should consist of the following. First, you have to review of the following papers, most 3 important papers. Okay. This you have to, particularly 1 and 2 are connected with HIP98. Okay. Number 3 is little old, but can be helpful. Okay, it's regarding in vivo measurements. So that is measurement, but for the calculations, you need to read into this 1 and 2. Okay, so description of the various hip contact force throughout the gait cycle for different physiological activities. So if you open HIP98, you can see yourself that there are perhaps 4 different activities that is corresponding to which they have calculated the forces as well as measured the forces as well. Now, these activities are fast walking, slow walking, stair up, stair down. Okay, stair up means climbing stairs, stair down is coming down the stairs. So like this, you can choose one particular activity. Okay. Now I have a report with me which actually discusses about or reports musculoskeletal force estimation using inverse dynamics for fast walking. Okay, so I will show you the report. So basically, you have to choose, first you have to understand the method, then you have to choose one physiology, one activity, and then how these things are calculated. You might have to show you the calculations. Okay, so that your understanding on the method of calculation is clearly exhibited. Okay, did you get the point? Hello?
Yes, sir.
Yes, sir.
So your understanding, take one activity, say slow walking, fast walking, either stair up, stair down. I know many students took great interest. They also got hold of some data and or use this data, and they for jumping also they had also come up with calculations. So it's up to you. Now, fast walking, slow walking, stair up, stair down, these are listed activities within HIP98. Okay. Going through HIP98, you have to first understand the whole process, and then you have to narrate your understanding in the project report. So that has to be very systematic. So you can see the inverse dynamic analysis of the lower limb. You take the lower limb, you draw the limb segment model, the diagram, take each limb
In the following video,
part,
we will be teaching
maybe draw the free body diagram, clearly giving the forces and moments occurring within a segment, line segment, I mean the limb segment. And then you perform the calculations. I will show you this report. And basically, the HIP98 an overview on its usefulness. So how you are within HIP98, what are the measured data? What are the calculated data? What are the transformations? Where are the local coordinate system? You know, you have to also do a lot of transformation of the data. So from local to global. So these things have to be clearly written so that it is in form of a report by which I can judge your understanding. I can judge your understanding on this topic. Okay. So is it clear now to you what you have to do exactly?
Yes.
Yeah.
Yes,
Now
sir.
I will just shift to the normal mode. So this I will make a PDF and submit to the teams, and you get more than a month. Okay, because in between, during the week 22nd of February to 26th of February, we will be holding the major test. And of course, inverse dynamics, musculoskeletal calculations, these are included in the major test. So even if you do proceed with your project, that will be also helpful, right? So we will discuss about that, but let me go to the interactive mode. Okay. Now, can you see me?
Yes, sir.
Hello?
Yes, sir.
Yeah. So this is the report I'm referring to, okay? So this is a hard copy report, so everybody can see with the 4 students' name here. A very nicely prepared report, okay? So it has musculoskeletal force estimation using inverse dynamics for fast walking case. So they have taken a fast walking case, okay? And so this is an introduction, right? So they have included a nice figure with introduction. They've given in one page the gait cycle, highlights of the gait cycle. Then there is anthropometric data and the linked segment model. Okay, everybody can see that?
Yes, sir.
Because that is required in your calculation. And of course, there is some linked segment model. So they have listed the anthropometric data in the table, the data they will be using for their calculations. Then you have the kinematic data that is measured. So it's very nicely step by step they have written down with supporting figures. Okay, ground reaction force versus time they have given. Then comes the limb segment angles, the joint angles, limb segment angles. Okay, center of mass of limb segment. So all these anthropometric data, they've used some MATLAB code finding the center of mass of each segment. Okay, so that is, they have used their MATLAB code. Then smoothing and curve fitting techniques. They have given a lot of data on acceleration of the limb segment versus time. Okay, so they have extracted the data from the HIP 98 and they have tried to plot it, and they do the curve fitting. Okay, to get these graphs during different sort of the gait cycle. After that, they have the basic line segment model equations. They have formed the equations, line segment. You can see. Now they are entering into the calculations. The main equations of inverse dynamics, the forces, the acceleration, I mean linear acceleration, then the angular acceleration, they are all narrated here. Okay. transformation of forces. So they have transformed the forces from one coordinate system to the other. And finally, they have actually attached a hand calculation. You see? They have attached this hand calculation. So in cases it was easier for them, neatly drawn free body diagrams with the coordinate system, the data, and they have shown the hand calculations, and they finally find out the reaction forces. Okay, they have found out the reaction forces and the moment at a particular joint. So they have shown this hand calculation using the data. And then finally, they present the results and discussion conclusion. So they are nicely presented. Even if there was hand calculation, this is a very good report. Okay. I'm concerned about the quality, the content in the report. So that's the reason I am showing it to the current students. Okay, so I hope you get an idea.
What's the weightage of the term project?
Weightage is quite, substantial. So roughly 15 to 20 marks, 15 to 20 marks.
So because it is incorporating a lot of the concepts that we have read till now, and also the fact that it will
summarizes.
Be very intensive. Yes, sir. So
Yeah.
it might be probably, if it's possible, can it be increased a bit more so that we can invest more time in that, and then it will also help us in the minor tests and everything.
No, this is, see, 20 marks is a lot of marks because in the continuous evaluation, we will have the major test. Okay. So major test, we will have two major tests. One is which one in February, the other one maybe in April. Okay. Regarding the two halves of the course. So part 1, part 2. So that will be, one will be out of 30, another will be out of 30. So that makes 60. Clear? The term project, if we take 20 marks, then it is, at this moment, we can discuss a little bit more. Term project, say 20 marks, that makes 80. And the rest is assignments, small assignments that we have already
So
done.
maybe we can reduce some of the assignments or tests and increase the marks for the term project.
We can do that later. Okay.
Sir.
Okay, sir.
Hello, sir.
Yeah.
Sir, both the assignments were returned, but our marks were not reflected there. So can you please tell?
It's almost ready. So let us. We will do that in this week. Sevi is in the class.
Yes, sir. Yes.
Yeah. So we can do that this week. Maybe Sebi can float it. Sebi, you need to just upload a PDF, but send it to me.
Okay.
Maybe if everything is finalized, then I can upload the PDF file in the Teams.
Yeah.
So we can discuss about mass distribution later on, but what I would advise all of you to concentrate on this part. We have one, tomorrow there is no class. Okay, so I'm traveling. Friday, SEBI will be giving a will be taking the class on static optimization. So the static optimization technique to get hold of muscle stresses, okay, and finally muscle forces. So that will be discussed by SEBI, and there will be, of course, you can ask questions regarding the technique. So that would end the first part of the course. Okay. I hope you had gone through the lectures that were presented on the human movements 1 and 2, and I hope you find it useful. So the last class of part 1 will be a specific discussion on the static optimization procedure. Okay, that will be presented by SEBI on Friday. Now I will be in Bhubaneswar on that day. I will try my best. I'm not exactly sure about what other official duties I have to do on Friday, because I will be on gate duty. But I think I can make myself available during that time from my hotel room. Okay. Hello.
Yes, sir. It's fine.
Okay. Now let us just brief you about the major test. Okay. You can devote your time now on this part of the course and try to gather as much knowledge as you can. Regarding marks, don't worry too much. Okay. You try to do your best. I will take care that the best possible marks can be given to any particular student. Okay. So that is, I do it uniform for the students, so I don't make rules for one student. I don't follow it for the others. Those things I don't do. Okay. People who are serious and committed, they should be awarded with good marks. And people who, there will be always some students not interested, doesn't show enough. It shows up in the activities, in assignments, in tests, everything. So there must be difference in the marks. That is a very simple logic. Okay. So students who are taking interest, they are learning the subject well, gathering knowledge, they have to be awarded with good grades. And students who are not doing that have to get lower grades. So this is pure and simple logic. Okay, so I have to ensure that. Now let us come to the major test. The major test has two parts. Okay, one is a MCQ. Perhaps you have noticed that we were testing the dummy quiz in the Teams, whether or not it was working fine. So with questions of what was the color of the sun, how many colors are there in the rainbow, something like that. One or two questions, and whether everything is working nice, we were testing it. Now the MCQ is of half an hour, 30 minutes. Okay? Can everybody hear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so it will consist of 25 questions, half an hour test. 30 minutes, 25 questions. Okay, they're very simple type, very basic, very simple. And I think Shivangshu was referring to difficult names to sort of remember the clinical terms, the clinical names of the muscles, ligaments, something like that. But I don't think you will have any problems if you roughly remember that conoid ligament is in shoulder. Conoid ligament is not in the knee joint. Okay, I hope you remember that. Okay, so knee has ACL, PCL, anterior cruciate, posterior cruciate ligament. So that ligament is not in the elbow or not in the shoulder. Okay, so these type of things. So you need to roughly locate where muscles, ligaments, all these things are there. And the questions are easy, and people who have followed the class, followed the lecture, the presentations, will finish it within 25 minutes for sure. Okay, the only thing is the questions are short, very objective type. But remember, there are some questions which has multiple answer correct. Okay, so not a single answer correct. There are multiple answer correct, and there is no credit for partial marking, partially correct answers. Okay, either you mark all the options correctly, or you don't answer it. Okay. So the questions, the MCQ is of half an hour duration. Just immediately following the MCQ, there will be a subjective test on problem solving and some little theories here and there. So that would be 1 hour. Okay, so say for example, if I do it on Friday, 11 o'clock the MCQ starts, 11:30 it ends. 11:35, within 5 minutes, you will be starting to, at 11:30 I will upload the subjective question, just like what you did in your assignment 2 test. You will be answering that question on your sheet, A4 size sheet, and scanning it and uploading it. Buffer time 15 minutes. So 11:35 say to 12:35. For example, say if we held the test on a Friday during our class. So 11:35 to 12:35 and 15 minutes extra buffer time for uploading. So 12:50 everything ends. Strictly.
Sir, has the date for this test been finalized?
No. We are going step by step. So let me first give you the idea of the content of the test. Now we'll discuss about the dates. So what is good for you? Evening? Hello?
Sir, class timings would be better.
Last time?
Class timings would be better, sir. Sir, Friday from 11 to 1.
Friday from 11 to 1? So we have to finish it by Friday.
Yes, sir.
And questions are ready. So today is 10th. My question is ready. Both the MCQ and the subjective question. But you need some preparation time.
So Friday will be good. Can we
Yes.
hold the test on 26th? Sir, the Friday.
From 11 to 1, between 11
Yes,
to 1.
sir. Yes, sir.
It will be good for everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Sir. Yes, sir. So,
You get some preparation time, right?
Sir, I
Yes,
think
sir.
if the
Yes, sir.
test like short short duration and it doesn't take much time to prepare, then we can also have it on 19th, because
26 is
since
No,
fine.
no,
20,
no, no,
Fine.
no, not
27th
that
to
urgent.
3rd is holiday, so people might have certain reservations on 26th as well, because 27 to 3rd is the holiday which was declared previously. So I'm not sure. I don't have any problem on 26th either, but just in case some people has reservations, so they might face difficulties.
Yes, sir.
Yes,
See,
19th to the
things cannot be convenient for everybody.
19th.
Okay,
Sir,
26th is a
26 is okay,
working
sir.
day.
Sir,
Yes, sir.
26 is better.
Yes, sir. 26 is
26 is
better.
better, sir.
26th is better.
Sir,
Sir.
26 will be better, sir.
Yeah. So it is a major test. Everybody has to be present. It is not by choice, but not by convenience, not by comfort. Okay.
Okay, so 26 works well.
It is
Thanks.
not by choice. When mid-semester is held on declared dates and times. Okay. So either you do it on 26th or any other day between 22 and 26. We can do it on Thursday evening, if you like, Wednesday evening, anytime.
No, sir. 26th is okay.
Wednesday.
Yes, sir. 26
No, sir.
is-
Sir,
26 is not
Wednesday
okay.
evening will be okay.
Yes, sir.
Thursday
Wednesday
evening will be
evening.
okay.
You can do it from, say, 7 to 9 during that block.
Yes, sir. So
Is
Wednesday
it
evening.
7 to 9
Wednesday.
okay or 6 to 8?
6 to 8, sir. 6 to 8.
6 to 8 sir, Thursday evening.
Wednesday evening.
Wednesday evening.
Wednesday.
Yes.
Yes, sir. Wednesday evening.
Yes, sir.
Sir,
Wednesday evening should be good. At least we had backup on Friday. If by any chance something goes wrong, then we can hold the test on Friday. So let us have date number 1 on Wednesday evening 6 to 8.
Yes, sir. This is better.
Hello?
Sir,
Yes,
please
sir.
fix it on Friday, sir.
Hello?
Sir,
Yes,
please
sir.
fix it on Friday, sir.
Wednesday is good.
So during class hours, it's better because at night, sir, families, everyone is home. So it's
Yeah,
not
yeah.
a problem.
Yes, sir. Class hours is better, sir.
Yes, class hours are better on Friday.
Sir, please fix it on
Yes, sir.
Friday.
On Friday is better.
No, Friday, the problem is that's the
Many
last day.
not available on
Yes, sir.
Friday. Many
Yes, sir.
people
Many
might-
people.
What?
So many people are not available on Friday because as holidays are declared from 27, so many people might be going, as Abhinav
Yes,
said.
yes. No. We cannot
I also have a
keep
reservation
it on a last day. Okay.
Yes, sir.
So Wednesday 6 to 8.
Yes, sir, that's good.
Yes, sir. That's good.
We have the
Yes, sir.
second line of defense on Friday, but the first date is Wednesday 6 to 8. Somebody said they had some problem on Monday. So except Monday, any date is open, but I think Wednesday 6 to 8 is a good option.
Yes, sir.
So let's freeze it on Wednesday 6 to 8. Okay?
Yes, sir.
Yes, sir.
So the first part will be
Yes, sir.
MCQ. Okay, we will be meeting before that. Wednesday we have a class, so we will be meeting and before the test. So anyway, everybody will be aware of it. But generally, I give a time of study leave for you so that you can recapitulate things and concentrate on the project. So doing the project is also preparing for the major test. Okay?
Yeah.
Shimanshu, where is Shimanshu?
Yes, sir.
Anubhav? 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 No, sorry, Avinav. Avinav Gupta? Are you there?
Yes, sir. Yes, sir, I'm here.
Yeah. So all okay? All fine? Wednesday 6 to 8?
Sir, yes,
Yes,
it
sir.
works. Sir. Yes, sir.
Yeah.
We have plenty
Yeah,
of
let
time.
us find a solution. Everybody should come forward to find a solution. We keep a second line of defense for Friday if something goes wrong. But before that, maybe if something goes wrong really on Wednesday, we should hold it on a Thursday first. So second line of defense, then the third option, Friday. Okay, don't keep it on Friday as the first option. Okay, and immediately see if you are interested, you can see the marks of the MCQ immediately. But I would not recommend anybody to see the marks because you might be disturbed because you should concentrate on the exam. So immediately within 5 minutes, you have to start doing the subjective, the problem solving, and some theory that needs to be narrated in your answer script. So that I would recommend that you concentrate on the exam. So the questions are set and in such a way that the knowledge component is highlighted. The knowledge of regarding the topics that have been discussed, the student who have followed the class and have really taken interest, they would find it quite interesting to answer the questions. Okay? Now, an answer to the query, Avinav. Avinav, are you there?
Yes, sir. Yes, sir, I'm here.
Yeah. So you asked about that elbow joint problem, right?
Yes, sir. During extension, why we ignored interosseous ligaments tension force.
Yeah, now there is, I just looked into it, okay? Now, if you visit page number 96, can I project it so that everybody can see it as well? Okay, share content. Not this one. Elbow 2. Now, if I go to 96, no. Please focus on this. And something, yeah. Can everybody see it?
Yes, sir.
Hello? Yeah.
Yes, sir.
Now this is the full extension case, page number 96. But here you can see at full extension, the moment exerted by these muscles, by the set of muscles, is augmented by the anterior capsular ligament, okay, which is somewhat stretched, which becomes stout means it is stretched. Okay, now the moment exerted by the muscles is augmented by the anterior capsular ligaments. Okay, and this ligament, the contribution of this ligament was long back quantified to an extent, and that was found out to be about 61.8 Newton meters of loading. Okay. Now this data was further used in the equilibrium equation, and you can see it here, M ligament. Are we now?
Yes, sir. It was used initially, but in the next set of calculations, only the support which muscles can provide, those from musculoskeletal system can provide.
I know. Just a moment. Now, in the equilibrium equation, after putting all the data, so you can see that this W comes out to be 288.9, out of which you can see if you divide 0.35 by 61.8 by 0.35, it actually, what it actually does is calculates the share of the load carried by the ligament. Did you think about it? That is why they are saying this is a large load, but note that more than half of it is supported by the ligament. Okay, so if you divide the whole term by 0.35, so the amount of load carried by the ligament is about 176 point something, which is more than the half of the total load. Now, what they are doing is the rest of the load is 112. So 176 plus 112 gives you about 288. So that is how it moves. So the rest is carried by the muscles. Did you get the point?
Sir, so in anterior capsular ligament, so there are a lot of ligaments, like it's like a whole capsule.
Yes, that is C. The problem is, Abhinav, to be honest, in this sort of simplified calculations, they are not going into the details of all the ligaments. They say within which, say, anterior, the capsular ligaments are there. Now, these are very rough calculations. So, if you want to really do a detailed calculation on the contributions of, say, muscles, ligaments, everything, then you have to really do, take it up in a far more detailed manner. Okay, this is to give you an idea. This is basically it's an idea how you use the static equilibrium equations to find out roughly the contributions of muscles and ligaments. Okay. Initially, we have shown you how the contribution of ligament can be quantified because there is an unbalanced force, and that may cause sliding of the in the elbow. So obviously, if there is no sliding, that means something is pulling it in the opposite direction, and that is the contribution of the ligament forces. So in a way, this is just to show you give you some basic idea. But if you really want to do detailed calculation, you have to follow the inverse dynamics principle and take into account, a lot of things. As you were saying, that there are quite a few ligaments within that, isn't it?
Yes, sir.
In that case, you have to really take up in a more elaborate way and with measurements, the kinematic data, and then you apply the inverse dynamics principle and calculate it. This is a very preliminary yet an important procedure using the static equilibrium equations, giving you an idea that how these whole set of musculoskeletal system acts.
Sir, I have just one doubt. So this anterior capsular ligament is located near humeroradial and humeroulnar joint in our musculoskeletal system. But the introosseous ligament that we considered in flexion of arm was located 8 centimeters from the joint and was acting between radial and ulnar bone. So was that introosseous ligament part of this anterior capsular ligament? Because since it encircles a group of ligaments, so is introosseous ligament also part of this? Have they considered contribution of it as well in this 61.8 Newton?
No. This is, they are saying anterior capsular ligament.
Yes. So why did they ignore that introosseous ligament that we considered in flexion calculations? They haven't considered it in this extension part.
Yes. Now that, see, as I told you, they are, in a sense, they are trying to show the contribution of, rather highlight the contribution of a ligament system in the whole elbow joint. Okay. Now, if I look back 11.22, the action of the interosseous ligament. If I go to page 94, here in the picture 11.22, you can see the action of the ligament on the proximal radius. Okay, but these are very roughly denoted things. Okay, now in the case of extension, I think what they are trying to say that this anterior capsular ligament has a major contribution. And that's the reason they are taking that into account and neglecting other ligaments.
Okay, sir. Okay.
Do you get my point?
Yes, sir. I got it.
They're trying to, because since that has a major, as I told you, see, in a system of muscle ligaments, musculoskeletal system in general, for a particular movement, not every ligament or muscle will be having major contribution. They are working in tandem. So for a particular activity, say movement, say flexion, some muscles and some ligaments has a major contribution. For another extension, some muscle might have little contribution, some muscle might have major contribution, similar to the contributions of the ligament. So this is, a very complex event. As I was telling you, say a cam, in a cam profile, the cam has an idler zone. So it is something quite analogous to that some muscles or ligaments will be idling. In another type of movement, they become very active. It becomes less active. If you, by any chance, see the shoulder, the paper of Journal of Biomechanics, the paper in Journal of Biomechanics by my supervisor Franz van der Helm, there is a lot of graph, okay, which is actually exhibiting the forces of the muscle with time and activities. So you will immediately recognize from the graph that, say, during abduction, say abduction of the shoulder, the contribution of trapezius or deltoids become very, very significant as compared to other muscles like supraspinatus, infraspinatus, this, that, or there is a host of muscles. There are about 17 to 20 muscles which are crisscrossing the shoulder joint. Now, it is something like that. Okay. So for a particular movement, a set of muscle or ligaments may be dominating are contributing in a dominant manner as compared to other muscles or ligaments, which may be dominant in another movement. Okay?
Yes, sir. Sir, the one possible reason I could think of why introosseous ligament was ignored, I was thinking about it a day before, is that the normal in case of flexion makes an angle of 30 degree with the longitudinal axis
Very
of a
roughly.
forearm.
Don't please don't take these values as the values. Okay? Be very
Yes, sir,
careful
roughly.
about these things, huh?
But I think in case of extension, when the arm is fully extended, this angle will reduce. So if that angle is reduced, the component of introosseous ligament will also reduce in the tangential direction.
Yes.
So
that
maybe
means
that's
with movement, the contribution of that ligament decreases with a different type.
Sir, I would like to add something.
Yes, yes.
Yeah, Sebi here. So I was just searching in the internet regarding this anterior capsular ligament. So I found a document which is related to this elbow anatomy and biomechanics. So they are discussing that this anterior capsule becomes taut in extension and lax in flexion. So
yes,
that is one of the reasons. So
I told you. So
yeah,
that is.
So interested students can just click on this link which I have shared in the message in chat box. But they haven't talked about this introosseous ligament. So I'm not sure whether.
What Abhinav also said that that is one reason. In principle, as I told you, depending on the movement, particular movement, one ligament may be dominant, the other ligament may idle in that situation or during that movement. So another movement, just the reverse thing happens. Okay, so during extension, the contribution of anterior capsular ligament is predominantly high, and it is contributing hugely in the whole load sharing mechanism, and it is stretched to the limits. Okay, but maybe during that time, this, as Abhinav explained, that this action of the interosseous ligament may be laxing.
Sir?
Yeah.
Hello, sir?
Yes.
Sir, I have one question regarding the slides which were sent, which were presented by Basil.
Yeah.
Sir, in problems like that, some moment of inertia is given. So how do we understand about which axis? So the way he calculated, so it was just given I, and then he took the moments about the center of gravity, that point. And sir, the joint axis where Rx and Ry are applied, why don't we take about that point? So, and in the calculations in that slide, he had also not taken Rx and Rx components for calculating the moments.
That is in movement 2, human movement 2, right? This one, right?
Yes, sir. So there are some examples.
Examples. I go to which example 1. Hello.
Yes, sir. This is just an example. I mean, there was a problem example afterwards.
This one, solution. Yeah.
Yes.
This one. Example 1.
Yes, sir.
Yeah, definitely. If there is something insufficient or something needs to be corrected, I will bring it to the notice, because we need to correct it. Yeah, as simple as that. So herein you are saying that the moment of inertia is not clearly indicated.
Yes, sir. And for the
which example? Example 1 or example 2?
Yes, sir. Example 1. And in point number 3, so where it takes the moment about center of mass, so there is no like the moment arm for Rx components.
Okay.
So it's just M2 and Ry and Ry.
No, definitely that needs to be corrected. If that is, yeah. COM.
So COM, why are we taking? So the point where that M2 is applying, that is like the center of pressure, right? And if you calculate about that, then Rx1 will have a component.
Just a moment. RY1 or Y2. Y1.
Sir, and at that point, Ry2 won't have any arm if we take about that point.
Where is the center of mass? Which point?
Sir, he mentioned that where that 0.9 G is acting, that is the point. So, but that doesn't. So, if that is the point, so that should have Rx1 also, Rx2 also.
Yeah.
And
Sir, I think there is a step missing, I guess, because in the first figure, they have only mentioned Ry, I mean the ground reaction force as a normal force. So the Rx component at the contact between foot and ground is 0. And Ax is, since Ax is 0, from the first equation, Rx2 is also 0, because Rx2 plus Rx2.
Yeah. Yeah, so there is a step missing.
Yeah, so since Rx1 is 0 and Ax is also equal to 0, Rx2 is also 0.
Yeah, but it would have been better if you had taken the moment and put Rx1 and Rx2 as 0. Showing
there
that
is just a single step missing between moment and the force.
Still, I think it is. Yeah. So did you get the point?
yes, sir. Yes, sir. I got the point. And sir, regarding the moment of inertia, like some axis needs to be mentioned, right?
Yeah, of course. But that is by default. You should know which axis.
But sir, like in the next example, there's an extended system. So like an arm, right? So it's not the center of the mass. So when it is an arm, it is like not 1/12 ml square. It's like 1/3. So because the joint is there. So in that way, I meant.
Okay. No, but that see those small things you have to. It's I think implicitly it meant like that. Okay. So here in that example, you can see they have taken Rx1. In the next example, as you can see, example 2, moment about the COM, Rx1, Ry1, these Rx1 is taken. Okay. Example 2.
In the example 2, since we have got a horizontal component for acceleration, we have this horizontal component of the reaction.
Yes.
But in the previous one, we didn't have a horizontal component.
But this Rx1 is used in the calculation. Moment calculation comes. Number 3, you see, in the equation M1 minus Rx1 into 0.0985. So, and Rx1, Ry1 both comes. And this is equal to the angular moment. So that I into alpha. It is more or less correct, but there are maybe 1 or 2 steps missing. Okay, Avinav?
Sir, I was Anirudh.
Oh, Anirudh, sorry. Yeah, Anirudh.
Yes, sir.
So it's good that you have indicated. So what do you it would help the slides to become better. So you would like to have the moment of inertia about which axis? You would like to see that? Hello?
Yes, sir.
Yeah. So that may be easily included. That's no problem because we have to anyway revise some slides. So the feedback is always good. Getting feedback from the students because we are in the process of floating this subject in NPTEL as well this year. So this course has been shortlisted for an NPTEL course, along with quite a handful of courses. So we'll be doing recordings as well as floating the slides in a more systematic manner. So all these feedbacks would be helpful in fine-tuning the slides as well. Thank you, Anirudh. Anything else? Hello?
No, sir. Not.
Okay, I think it is time. So, Abhinav, I think SEBI has given that comment. Okay. Abhinav?
Yes, sir, I'll check it.
Yeah, just check it. And hopefully I see you on Friday. Don't miss the class on Friday because SEBI will be presenting an important topic on static optimization of muscle stresses. Okay?
Yes, sir.
Okay. And that would be the last formal class of this part of the course. Okay? Thank you. Hopefully I'll see you on Friday as well from a different location. Okay, thank you everybody.